In this section, we will discuss the main power motor circuits of three types of diesel electric locomotives. That is, WDM2 DC-DC locomotive with a single BKT and reverser, WDM2 AC-DC locomotive, and WDM3A locomotive. This is the main power motor circuit for WDM2 DC-DC locomotive with a single BKT and reverser. In this circuit, these are the 6 traction motor armatures, and these are the respective traction motors fields. These are the 3 series power contactors. These are the 6 parallel power contactors. These are the BKT contacts in motoring mode. And these are the reverser contacts in reverse or forward direction. This is the main power motor circuit for the WDM2 AC-DC locomotive. The difference between the main power motor circuits of WDM2 AC-DC locomotive and WDM2 DC-DC locomotives are as follows. Number 1. The main power motor circuit of WDM2 AC-DC locomotive does not have this BKT contact because this BKT contact is used in dynamic braking circuit by connecting it to the traction generator via the series field. Number 2. The main power motor circuit of WDM2 AC-DC locomotive has the traction alternator and the rectifier in place of the DC traction generator. The AC output of the traction alternator is fed to the rectifier, and the rectified DC output is then fed to the 6 DC traction motors via the cable number GA11 and GA2. This is the main power motor circuit for the WDM3A locomotives. All the WDM3A locomotives are AC-DC and do not have field shunting. Hence, the difference between main power motor circuit for WDM2 AC-DC locomotive and WDM3A locomotive is that there are no field shunt resistance and FS contactors in WDM3A locomotives. The logic of the flow of current in all the 3 circuits is the same. Now, we will discuss the working of the main power motor circuit by reference to WDM2 DC-DC locomotive with a single BKT and reverser. The main power motor circuit works in 2 combinations of traction motors. The 2 series 3 parallel combination or the 2S3P combination and the parallel combination or the 6P combination. At speed below the specified limit, the main power motor circuit works in 3 parallel circuits across the traction generator. Each of these 3 parallel circuits has 2 traction motors in series. The traction motors in this combination are as follows. Traction motors 1 and 4 in series, traction motors 2 and 5 in series, and traction motors 3 and 6 in series. Therefore, this combination is also called 2 series 3 parallel combination or the 2S 3P combination. Wheel slip protection is provided by Wheel Slip Relay 1 or WSR1 in case of 1-4 combination, WSR2 in case of 2-5 combination, and WSR3 in case of 3-6 combination. The wheel slip relay works on the principle of Wheatstone bridge. Whenever the potential difference between the two traction motors exceeds the tolerance limit, the WSR operates, because of which load reduction occurs and the driver gets the alarm indication in his cabin. The faulty traction motor can then be isolated using the motor cutout switch or the MCOS. The direction of the flow of current depends upon which side the potential is higher. Under normal condition, the potential difference is within the tolerance limit and the wheel slip relay remains in balanced position. In the 2S3P combination, all the 3 parallel paths get energized simultaneously. The current starts from the traction generator and energizes cable GA11 and completes its path via GA2 and the traction generator. We will discuss each of the 3 paths separately for education purpose. We will now discuss the current flow in the traction motor's 1-4 combination. The current from GA11 energizes traction motor 1 through cable A1, BKT contact 9 in the motoring mode, cable number 41J, reverser contact, the field of traction motor 1 and flows through the reverser contact. To measure the armature current, the load ammeter shunt is connected in series with traction motor 1 and the armature current of traction motor 1 is indicated in driver's cabin by the load ammeter. The current flows through series power contactor S1 via cable number 41V and energizes traction motor 4 via cable A4. The field of traction motor 4 is energized via cable AA4, BKT contact 4 in the motoring mode, cable number 40B and the reverser contact. The current completes its path through cable GA2 via reverser contact and BKT contact 3 in the motoring mode. The wheel slip protection in the 1-4 combination is provided by WSR1, which is connected through the normally closed interlock of the parallel power contactors. Let us now take a look at the current flow in the traction motor's 2-5 combination. The current from GA11 energizes traction motor 2, BKT contact 7 in the motoring mode, cable number 41, reverser contact, the field of traction motor 2, reverser contact, cable number 41S. This current flows through the series contactor S31 via cable number 41S and energizes traction motor 5 via cable number A5. The field of traction motor 5 is energized via cable AA5, BKT contact 2 in motoring mode, cable number 41E and the reverser contact. The current completes its path through cable number GA2 via the reverser contact, cable number 41L and BKT contact 8. Wheel slip protection in the traction motors 2-5 combination is provided by WSR2, which is connected through the normally closed interlock of the parallel power contactors. And the current flow in the traction motors 3-6 combination is as follows. The current from GA11 energizes the traction motor 3, BKT contact 6 in motoring mode, cable number 41C, the reverser contacts, field of traction motor 3 and flows through the reverser contact. This current further flows through series power contactor S21 via cable number 41P and energizes traction motor 6 via cable A6. The field of traction motor 6 is energized via cable AA6, the BKT contact 1 in motoring mode, cable number 40 and the reverser contacts. The current completes its path through cable GA2 via the reverser contact and the BKT contact 5 in motoring mode. Wheel slip protection in the traction motors 3-6 combination is provided by WSR3, which is connected through the normally closed interlock of the parallel power contactors. As transition takes place above specified loco speed, the series power contactors drop and the parallel power contactors pick up, because of which all the 6 traction motors get connected in 6 parallel combinations between cable GA11 and cable GA2 through the main contacts of parallel contactors, armatures of the traction motors, main contacts of BKT in motoring mode, contacts of reverser, and the field of traction motors. Wheel slip protection in the parallel or 6P combination is provided by wheel slip relays connected across pairs of traction motors as follows. WSR1 connected across traction motors 1 and 5, WSR2 connected across traction motors 2 and 3, and WSR3 connected across traction motors 4 and 6. Let us now discuss the current in these parallel combinations or 6P combinations. The flow of current in all the 6 parallel circuits is simultaneous, but for education purposes, we will discuss the flow of each parallel circuit one by one separately. The current flow in the parallel circuit of traction motor 1 is as follows. The DC output of the traction generator energizes cable GA11, because of which the traction motor 1 is energized via cable A1. The field of traction motor 1 is energized via the load ammeter shunt, BKT contact 9 in motoring mode, cable number 41J and the reverser contact. The current flows through power contactor P2 via reverser contact and completes its path via cable GA2. The current flow in the parallel circuit of traction motor 5 is as follows. The current from GA11 then flows to power contactor P31 and energizes traction motor 5. The field of traction motor 5 is energized via cable AA5, BKT contact 2 in the motoring mode and the reverser contacts. The current completes its path via cable GA2 through the reverser contacts, cable number 41L and the BKT contact 8 in motoring mode. The wheel slip protection is provided by WSR1, which is connected across traction motors 1 and traction motor 5 through the interlocks of parallel power contactors. The current flow in the parallel circuit of traction motor 2 is as follows. The DC output of the traction generator energizes cable GA11, because of which the traction motor 2 is energized by cable A2. The field of traction motor 2 is energized via BKT contact 7 in motoring mode, cable number 41 and the reverser contact. The current flows through power contactor P32 via reverser contact and completes its path via cable GA2 via the BKT contact 11 in motoring mode. Let us now see the current flow in the parallel circuit of traction motor 3. The current energizes the traction motor 3 via the cable A3. The field of traction motor 3 is energized via BKT contact 6 in motoring mode, cable number 41C and the reverser contact. The current flows through power contactor P22 via the reverser contact. Wheel slip protection is provided by WSR2, which is connected across the traction motor 2 and 3 through the interlocks of parallel power contactors. The current flow in the parallel circuit of traction motor 4 is as follows. The current flows through power contactor P1 and cable A4 and energizes traction motor 4. The field of traction motor 4 gets energized via cable AA4, BKT contact 4 in motoring mode, cable number 40B and the reverser contact. The current flows through reversal contact and the BKT contact 3 in motoring mode and completes its path via cable GA2. Let us now discuss the current flow in the parallel circuit of traction motor 6. The DC output of the traction generator energizes cable GA11, which further flows to traction motor 6 through cable A6 and power contactor P21. The field of traction motor 6 is energized via cable AA6, BKT contact 1 in motoring mode via cable number 40 and the reverser contact. The current flows through reverser contact and BKT contact 5 in motoring mode and completes its path via GA2. The wheel slip protection is provided by WSR3, which is connected across traction motors 4 and 6 through the interlocks of parallel power contactors. During first field shunting, that is at speed of 30 km per hour, and second field shunting, that is 78 km per hour, during both series and parallel combination, FS contactors FS21 to FS26 will be energized through FSR and the current will flow through FSPR.